Yeah. So today is, let me share the screen. So last time we talked about model and how is the model connect to our life, and I give some examples, and I hope you do the over-assigned questions. Today we're going to start for a new section is P2. The new section is P2 is real numbers. We will start about talking about real numbers. So P2 real numbers. Here. Okay, okay. Yeah, real numbers. So what's real numbers? So the real numbers is a set of numbers. This set are made up by sets of numbers, different sets of numbers. So real number is a set of numbers is made up by sets of numbers. What is this set of numbers? First set is natural number. Natural numbers. Who know about natural numbers? What is natural numbers? As you take it in high school. What's natural numbers?
Whole numbers?
All numbers? Like what? Like, give me example for natural numbers.
I said whole numbers like 1, 2, and 3.
What about -1? It's a natural number?
I believe it's not.
It's not. So natural number is, what about 0? Is a natural number?
Yes.
0 is not.
Oh, sorry.
So okay. So natural number is all positive numbers look like this without fraction to infinity. 1, 2, 3, 4, 5 to infinity without fraction. Like everything positive, not fraction. Okay. This is called natural number. The 0 is not natural number. Okay. The 0 is not natural number. So natural number is 1, 2, 3, 4, 5 to infinity. Second set that made up the real number is integer numbers. Integers. Numbers. What is integers numbers?
Every number on the number line?
Every number in what?
In the number line?
Like, can you give me example?
like -10, -9, 0, 1, 2, 3, so on and so forth.
What about 1/2? Is integer
Yes, it
number?
counts. Yes.
No.
Alright.
So, okay, integer number is the positive natural number, and it's the negative of the natural numbers and the 0. That means the fraction is not integer numbers. 1/2 is not integer number. Okay, so the integer number is the natural numbers and the negative of them and the 0. What does that mean? This means from minus infinity. Hold on. This means from minus infinity, -3, -2, -1, 0, 1, 2, 3 to infinity. The fraction is not integer numbers. Okay. Here, the natural numbers we denoted by n, like this. And here, the integer numbers denoted by z. Okay. First set that made up the real number is called rational numbers. Rational numbers. What is rational numbers? Who will give me the definition of rational numbers? Yes. What is Chris? What's the rational numbers?
So usually a rational number is something that could be divided. So it could be anything from
Okay.
16, 8, 4.
Okay,
They're
like
usually
anything.
positive numbers, aren't they?
Exactly. So any integer numbers, like it's look like any two integer numbers divided by each other. It's give me rational numbers. So the rational numbers is the natural numbers, the integer numbers, and anything look like ratio. Anything look like fraction. So I can define it as are the ratios of integers. This is the integers, like I denoted here. The ratio of integers. For example, I may if I want to explain more, it's look like the numbers as r equal m over n, such that n, m, and n r belong to the integer numbers, and m not equal 0. Here n not equal 0. Why n not equal 0? Do you see number like that before? Did you see numbers like that before? Who see numbers like that before? 3 over 0 or 1 over 0, for example. This is undefined. This is undefined number. That's why n here must be not equal 0. Okay. So here, m and n, both of m and n are integer number, and n not equal 0. So who will give me example for rational numbers? Who can give me example for rational numbers? Yes. Asrar.
1/2, 1/4,
One
1/3,
half, one half. What else?
1/3.
1/4, 1/3. What about the number 3? Is rational number?
Yes,
Yes. Why?
because it can be put as a fraction.
3 over 1 as a fraction, and 3 over 1 is 3, right? And here is 1, so 3. 3 is a rational number. What about like 5 over 2 is rational number?
Yes.
Yes. So any fraction look like this, such that the numerator and denominator, both of them are integer numbers, but the denominator here must be not equal 0. Why? Let me talk about this. Because they give me undefined number. The undefined number it look like this: 4 over 0, or any number over 0. Okay. Yes, Denise.
Oh, I wanted to know what the notation meant, like when you have like n equals m over n and then followed by the comma. What are those symbols? I missed that.
Which for what? Symbols for what?
So
Can you
for
repeat it?
under rational numbers, you say like there's like an example. It's like n equals m over n. Then there's like a comma. You
Yeah.
see that?
Oh, yeah. Okay. So r equal m over n, such that here comma. This comma means such that m and n are both of them are in the set here of the integer numbers. So let me explain this more. This will mean both of the number m and the number n are integers, and in the same time n not equal 0. I explain your answer. I answer your question.
Yeah, that was
Did I
perfect. Thanks a
answer you?
lot. I appreciate it.
Okay. You're welcome. Any questions so far? Okay, let me go. Can I go to the next slide? Nadine, minus 4 over 6. Yes, it is a rational number. And 4 over 6. Yes, it's a rational number. Okay. Okay. Here we denoted by for rational numbers by Q. We denoted as the set as Q. Here we denoted by Z. Here we denoted by N. Let me put in different colors. Here, this is N here. Here is Z, but look like this. And here is Q. Okay, next. The fourth set that made up the real number is called irrational numbers. Number 4 is irrational. irrational numbers, any numbers. What's the irrational numbers? Who can give me information or definition of
Like an
irrational numbers?
so let's imagine like three over two will be a rational number.
3 over 2.
Yeah.
This is rational. This is
Oh.
rational. Because the 3 is integer,
Oh, so
2 is integer. Yes, that's right.
1/3.
1/3. Hold on. What is the bin? 1 over 1/3. It is irrational, but 1 is integer number and the 3 is integer number, so this is rational. So this is not example for irrational numbers.
Is it like radical numbers? So it's
like what?
Radical numbers, radical 3. Can it be radical 3?
What about radical 4?
well, wouldn't that be 2?
Yeah. So that
This is the radical 4. Radical 4 is equal to, and 2 is like, who open the music? Can you turn off the music, please? Okay, so radical 4 is equal to, and 2 is rational number. Why?
So no, turn it down. I didn't say change, I said turn it down. I didn't say turn it off. Turn it down.
Let's turn it down.
The volume.
Can you turn off the sound, please? Excuse me. Yes. So radical 4 is equal to, and 2 is rational number. Why? Because 2 is equal to 2 over 1, and this is rational number. But what about radical 2? Is irrational? Do you think?
Nothing that's irrational.
No.
Yes, it's rational. Why? Because square root of 2 or radical 2, I cannot write it as a fraction, like number A over B, such that A and B are integer and B not equal 0. So square root of 2 is irrational. What about square root of 3? Can I write it as a fraction?
Oh,
no, I can't write it as a fraction. So it's irrational. This is irrational. This is irrational. So the irrational, I can define it as is set is anything I can write it. I cannot write it as a ratio of integers. Any number I cannot write it as a ratio of integers. Example for that, square root of 2. I cannot write it as a fraction, A over B or something. I cannot. Square root of 3. Square root of 5. What about pi? Yes, pi, I cannot write it as a fraction. I cannot. What about square root of 2 over pi? Yes, this is example for irrational number. What about square root of 2 over pi square? Yes, it's irrational number. So this one, this one, this one, and that one, and this, example for irrational numbers. Okay?
So
wait, that means it's not rational?
No, they are irrational numbers. Why? Because I cannot write it as a fraction. Cannot write it as A over B. I cannot find number A and B integers that explain or that equal to square root of 2.
So even though it's 2, it's the square root of 2 over pi, and that is a fraction, that is still irrational?
This is a fraction, but But this is here, the fraction here, this integer, this is not integer, and the pi is not integer too.
Okay.
Understand?
Yeah.
Pi is not integer because pi is equal, it's close to 3.14 something numbers here, and this not integers. Okay.
So, another example of an irrational
Here,
number
look.
could be like 3.333.
Hold on 1 second. Here's a ratio of integers. Look to the definition. Ratio of integers. This is not integer. This is not integer. What's your question?
And I said that another example could be like 3.333, no?
3
Because it's like undefined.
333.
Like a constant decimal.
Constant decimal, but different decimal, like 4, 5, 6, 7, 1, 2.
Yeah.
Like not, it's not repeated. This is example of irrational number. Yes, this is true.
Okay.
Professor, I had a question.
Yes.
What if the question is like square root 9/3? Written
9
like
over
that,
3.
yes, written like that, it would be
This is-
considered irrational, correct? Or
This is the rational.
because when you
This is the
simplify,
rational number. Why? When this is 3. Square root of 9 is 3 over 3. Both of them are integer, and also this is equal 1. And the 1 is rational number because 1 over 1, I can write it as ratio of integers. Anything can I write it as ratio of integer is called rational. Anything I cannot write it as a ratio of integers is called irrational. I hope I answered your question.
yeah, you did. Thank you so much.
No problem. So this is here rational number. Any questions so far? So all these sets, rational, irrational, and integer, and natural numbers, all of them are made the real numbers. So this is the real number. This is real number. Any number is like any number from this set are real number. So what's the real number? It is the sets of all these sets. Okay. Let me like draw a diagram, explain more about the real number. So the real number, it's like big set. Look, it's like big set. It's called here real numbers. Inside this big set, we have sets, small sets. Here, it's called rational numbers. Here, irrational numbers. Inside this rational numbers, I can make a small set like that. It's called integers numbers. Inside this, I'll make it smaller, right? So inside this integer numbers, I can make a small set here. It's called natural numbers. So look, let me use different colors. So again, all this big set all this big set is the real numbers. This is the real numbers. Inside this big set, we separate it to different parts, rational numbers and irrational numbers. The rational number inside this set here, integer numbers. Inside the integer numbers, natural numbers. I give you again, let me explain more. So here, for example, natural numbers is number 1, number 2, number 3 to infinity. Integer numbers like -3, -2, -1, and the 0, and the natural numbers 1, 2, 3. It's inside the set. Rational numbers, anything look like A over B. Like for example, 1/2, 1/3, and number 1 is rational number. -2 is rational numbers. 1/4. Irrational numbers like square root of 2. This and like pi square, pi over 2, like over square root of 2. Yeah, what's your question, Nadine? What do you mean 0 consider a whole number? Yeah, exactly. No. 0 is not considered a whole number. 0 is rational number, but is not irrational number. The 0 is rational number, but is not irrational number. Okay? The 0 is inside the rational numbers. Any questions so far? So,
Yeah. Oh,
yeah.
Professor, I'm sorry, I don't know if I caught this, but are irrational numbers denoted by a letter?
Yeah, denoted by
Oh.
Q.
Rational or
But-
irrational?
Irrational Q bar.
Okay. Thank
I
you.
forgot to talk. Yeah, Q bar. Again, here irrational numbers. Here numbers are denoted by Q as bar. This means irrational numbers. Integers denoted by Z. Natural denoted by N. Look like this. Okay. Any questions so far? Okay, let's now go to the properties of these real numbers. Here. Properties of real numbers. So what's the properties of real numbers? First property is called commutative property. What does that mean? This means any two real numbers, A and B, if I do sum for both of them, I start from A to the B, add A to the B, is the same as I add the second one to the first one. So A plus B is the same as B plus A. If I start adding the first number to the second number, is the same as adding the second number to the first number. It's called commutative property. The same things for multiplication. A times B is the same exactly B times A. Okay? If I multiply this, the A the first number to the second number is the same as multiplying second number to the first number. This means the order does not matter. Okay, order doesn't care which is the first. I want to add it to the second one. Does not. Okay, I give you example. Who will give me example for this? Who will give me
Yes.
example?
So like what's it called? 1 plus 2 is the same as 2 plus 1, or 1 times
Yes.
2 the same as
1 times 2 as 2 times 1.
Yeah.
Like it doesn't matter where I start. If I want to start from the first one to the second one, is the same as starting the second one to the first one. This is called commutative property for real numbers. Second property, number 2, is called associative. Associative property. Here, property. So what's the associative property? This means if I have 3 real numbers, a plus b parentheses plus c is the same as uh, a plus b plus c and the parentheses here. This means if I want to add these two guys together, then the answer for this adding to the third one is the same exactly. Adding the both of the back, then the answer added to the first one. This means doesn't matter which two we add first. The same thing for multiplication, AB, multiply both, then multiply by C is the same exactly A multiply for both of BC. This means again, then here does not which two numbers we added first or multiplying first or multiply first. So if we start by these two numbers, then we add the result for this one is the same as adding this both, then adding this result to the first one. Doesn't matter. Example for that. Who would give me example?
So it's like 2 plus 4.
2 plus 4. Parentheses.
Plus
plus
5.
5.
Equals
what?
2.
2 plus
4 and 5. 4 plus 5.
4. Yes. Exactly. Why? So look here, 2 plus 4 is give me 6, right? Plus 5. And this is exactly like 2 plus what does this give me? 9. And for both answers, they give me 11. This is give me 11, and this is give me 11. Associative property are achieved for real numbers. Same things for multiplication. Let me give me another example for multiplication. For the same numbers, by using the same numbers, 2, 4, 5. So 2 times 4, well, all of them times 5 is the same as 2 times 4 times 5. Let me make sure. 2 times 4 is 8 times 5, and is to equal 2 times 4 times 5 is 20. 8 times 5 is 40, and 2 times 20 is 40. So the associative property are achieved for multiply also. Any question before I go to the next slide?
So I had a question. I know we're not in this part yet. It was about the homework. It's all about cause. So would something like this apply to a cause situation, or is the formula different?
In which homework you're talking about?
Because in the homework there's a cause formula, like a specific formula. But I guess that has to do more with like mileage and stuff like that, right?
You're talking
Like
about Wilberson homework?
On the yeah.
Okay, so okay, for about the Wilberson questions, keep it to the end of the class, or you can email me for any question. So about this, everything is clear here for this slide. You have any question for this slide here?
No.
Okay, perfect. So again, if you have for the Wilberson question, you can email me about your question, or I will like in the end of the class, you can ask me your question. So now, also we have another property, it's called distributive property. This is a very important property. Third one is called distributive. What is distributive property? For example, if I have the real number A times two numbers, this is equal exactly like distributing A to the both of inside the parentheses, A times B plus A times C. Okay, and the same thing here, B plus C times any real number. Again, we distributed the A inside the parentheses. You give me AB plus AC. It's clear, this property. So example for that. Who will give me example for that? Who will give me example for distributive property?
So like what was it? A could be 4.
A could be 4. Okay.
So and B would be 6.
6 plus.
And yeah, and 8.
8. Okay. Okay. So the distributive property here said 4 times 6 plus 4 times 8. And this will give me 4 times 6 plus 4 times 8. What's the answer? 4 times 6 is 24 plus 4 times 8. What is 4 times 8?
No, 32.
32. And what is the answer? Sorry, 55. 65. Any question for this? Same things if we do 6 plus 8 times 4 could be the same thing with distributive the 4 to inside the parentheses. 6 times 4 plus 8 times 4. And this will give me 24 plus 32. And they give me 56. Do you have questions for distributive property? Okay. So let me give you examples about more examples about the distributive property. Can I go to the next slide? Okay. So here, example. Here's the question. So order does not matter for distributive property. Yes, exactly. Here, the order does not matter for distributive property. Why? Because look, A times here AB plus AC, and this is equal, like I said before, by using the first property is called commutative property. By using the commutative property in the first property I talked about, AB is the same as B times A, and AC is the same exactly C times A. And again, this is equal to the similar to this one. Why? Because this is B times A. If you go here, this is B times A plus C times A. And this is exactly look like this. Is AB plus AC by using the first property, commutative property. I answered your question, Christopher?
I had a question. So you're saying that that the last two that you just added, they're just relative. They're like another form that equals the same
This
thing
one?
for those. Yeah.
Okay, let me explain more. Okay, I will go back again to explain. Look, so here, A times B plus C, we distributed the A to the both inside the parentheses. They give me A times B plus A times C. Again, this is equal by using the first property. If we go back to the first property, that's it, commutative property. A times B is the same as B times A, exactly. Order does not matter. So here, A times B is the same exactly like B times A. And A times C is that exactly C times A. And this is exactly look like B plus C times A. This here looks like this. B times A plus C times A. So this means this formula exactly to this one. So answering to that Christopher question, order does not matter for distributive property. I hope it makes sense for you. Okay. So now let me go to the examples. The first example is said answer this one by using that distributive property. This is number one. So what is this equal? What is that equal?
2x plus 8.
2x plus 8. 2 times x plus 2 times 4. And this is equal to x plus 8. Second one. A plus B multiplied by C plus B. What is the answer?
AC. AC.
Okay. I will simplify this one by using the same idea by before. I multiply the A to the whole parentheses and multiply the B to the whole parentheses. It makes sense? I mean like A times C plus D plus B times C plus D. Make sense? Yes, Amanda. What's your question?
So the final format for like a question like this, you would have to write it like that? Or can you simplify it even more than, or would you have to simplify it more than that? Or is that an okay answer to give?
For the question number one, for example one?
Or number two?
Oh, no, we have to simplify it more. So what's the simplifying for this one? Is A times C. Again, we distribute it again. AC plus AB plus B times C plus B times D. This is the final answer. Okay. Anyone has a question?
I got a question. Can you just put AC plus AD plus BC plus BD, or do you have to put the multiplication sign?
Oh, you can write it as AC plus AD plus BC plus BD without the multiplication sign. Okay. It's now
Another
go to
quick question. Sorry.
Yeah.
Where can I find the uploaded lectures on Blackboard? Sorry, it's unrelated.
What they need? Can you repeat your question?
When you when you upload the class to Blackboard that you record, where can you find it?
Yeah, I will. I did not upload it right now, but I will like using the YouTube to uploading the video. Okay, I will make a channel and uploading the video for the class.
Okay, thank you.
I will let you know about the channel by tomorrow or after. I will send you the link for the playlist for all recording. So here I will give you example by numbers, like for example 2 plus 3 times 4 plus 3, or I don't want to use 3, I want to use 5. So what's the answer again here? We distribute the 2 for both for the same parentheses. 2 times 4 plus 5 plus 3 times 4 plus 5. So what's the answer? Who will help me? 2 times what?
9.
4 plus, yeah, you can like adding it then multiply, or you can distribute it again. But I want to use the distributive property. Okay. So 2 times 5, 3 times 4, plus 3 times 5. What's the answer? 8 plus 10 plus 12 plus 15. What's the answer?
Is it 45?
45. Any questions so far about distributive property? It's clear for all students? Okay, let's go. So I'll give you like 1 minute to move to the next slide. So now let's go to the next slide. Addition and subtraction for real number. Addition and subtraction for real numbers are. So I denote it by real numbers. I denote it for real numbers by the symbol R. So we have some properties here. The properties are, we have some properties. For the addition and subtraction of real numbers. Oh, the first one is -1 times A. A is a real number, is equal minus A. Who will give me example for this one? Like for example, if I want to choose A, any real number, -1 times 7. What's the answer?
-7.
-7. -7. Same thing for any real number. A here, A is a real number. R here means the real numbers. Real numbers. Richard. R is the real numbers. Okay. Second property. Said minus times minus A. If I have negative number here, okay? If I have negative number, this is equal A. Okay? So that A again is real number. Okay? So I give example. Who's giving example? Small example for this one. Minus what? 8 is good. This is equal 8. Minus 3 is equal 3. Minus 4 is equal 4. Minus square root of 2, you give me square root of 2. Third property. What is minus A times B equal
Negative AB.
negative AB. That's true. What else?
Negative BA.
A
Yeah.
negative BA. Yes. Example for that. It takes minus 2 as A times 3. This will give me the negative outside 2 times 3. And this is equal 2 times negative 3. All of them are equal. And the answer is minus 6 for all of them. Another example, minus 4 times times 5 is equal minus 4 times 5. And this is equal 4 times minus 5. And this is equal minus 20 for all of them. So this property are achieved for real numbers under addition and subtraction. You don't have to memorize this properties, but you have to know how to use this property. Any question before I move to the next slide? Does each property have a name? No, does not. Okay. Let's go to the next slide. Property number 4. It says minus A times minus B is equal AB, because minus minus is positive. That's why they give me AB. Example for that, you can take any numbers, like for example, minus 2 times minus 3. Give me positive 2 times 3, and this is equal 6. Or another example, minus 4 times minus 5. You give me 2 times 5. Why? Because the negative is positive, and sorry, 4 times 5. 4 times 5 is 20. Okay. Five property. That minus parentheses A plus B. So this exactly looks like the distributive property. The third property we talk about. We distribute a minus inside the parentheses. Look, it looks like minus A minus B. Who will give me example for this one? I'm waiting. Who will give me example?
5 and 9.
Minus what? 11 and 9.
Yeah.
So what's the answer? Minus what?
Negative 11 and
minus
negative 9.
What's the answer? Yes, negative 11, not negative 9. The answer is negative 20. So here, what does that mean, negative 20? This means this part is equal to this part. Why? Because negative times here, explain more. Because here is the same, this part here is minus 11 plus 9 is 20. This is equal, here we do summation. They give me minus 20 direct. And here, by using the first property in the back, see the first property here? Minus 1 times any number is the same as minus the number. So again, minus times negative times 20 is the same as minus 20. And both of them are equal. The last property is number 6. Minus A minus B. What is the answer? The answer is B minus A. Why? I'll explain more. We distributed the negative inside the parentheses, and this is give me negative A, negative is positive B. And again, this is equal because I said the commutative property for real number is achieved. So it's equal B minus A. And this is the answer here, B minus A. It's clear? Okay, let me give you example for the last one. Suppose we have minus 2 minus 4. This is equal 4 minus 2. And this is equal to. We start from the second part, but positive. And the first part is negative, and they give me 2. Another example. Minus 6 minus 3. You give me 3 minus 6. And the answer is negative 3. I give you another example. What is the negative of x plus 2? Who give me the answer?
Negative
What's
x,
the answer?
negative x
Negative x
minus 2.
negative 2,
Yeah.
right? Yes, negative x minus 2. Okay, another example. Negative x plus y minus z. What is the answer?
Negative x minus y
Negative x
minus y
minus
plus
y
z plus z
uh,
plus z.
plus z. Yes, that's true. Or it's minus z. Like I can explain more here. Here is oh sorry. Are you here? The connection is something happened to the connection. Do you hear me clear, everyone?
Yes.
Okay. So for the last one, here minus times x plus y minus z. So again, how is my sound? Is it clear for everyone? Do you hear me clearly? Okay, what is the answer for this one? Is minus x minus y minus z. And again, minus x minus y minus z with distributive positive z. Any question? No questions, right? Okay, so now we finish the sixth property for the addition and subtraction. Another property for multiplication and division. Again, the real numbers, they have a property for multiplication and division. So multiplication and division. So we have yeah. So we have some properties. The sound is clear. Sorry for that. Okay. So again, multiplication and division. Multiplication and division. So we have properties again, like addition and subtraction. We have another properties. First property, first things before I start for the property, A divided by B, when I see something like that. Yes, when I see something like something like that. Here, A divided by B. What does that mean? Who
It
can
could
answer?
mean like a fraction.
Fraction could be as a fraction, exactly. Or could be like something like this, A times 1 over B. And this is equal A over B. So we can change the division sign to multiplication. Then we flip the B to 1 over B. And this gives me 1 over B after we do multiplication. So, and this is called, what is that called here? Numerator. And this is called the denominator. So let me start for the property. First, the property said A over B times C over D equal what? For multiplication,
Do you multiply like what was it, A and D, or
when we see fraction times a fraction, we try to multiply the both numerator together and both denominator together.
so you just cross? I mean, you just multiply across.
Yeah, A times C over B times D. No cross multiplication, nothing. If there is here multiplication, we multiply the both numerator together and the both denominator together. And this will give me AC over BD. Is good?
So we just cross multiply when it's multiplication.
It cross multiply for addition. I will talk about this. For multiplication, if I have two fractions multiplied together, I try to multiply both numerator together, A times C over B times D. This is the first property. I give you example. 3 over 4 times 2 over 5. What is the answer? What is the answer?
Is it 6 over 20 or
6 over 20? Yes. We do 3 times 2 over 4 times 5. You give me 6 over 20.
could you what's it called, simplify even more, or
We can simplify it more by dividing both sides by
2?
2. So what's the answer?
3 over 10.
10. Yes. Okay, second property. So this is called multiplication fraction. Here. Second property is division fraction. A over B divided by C over D. What's the answer? So the answer is A over B multiply, we flip this fraction to be d over c. Then we go back to the same first property, ad over bc. Is it clear? So for division, we flip the second one and we do multiplication. Example. Three over 5 divide by 3 over divide by 4 over 6 or over 7. What's the answer? What is the answer?
3 over 5 times 7 over 4.
Times 7 over 4. And this is equal?
What's it called? 21 over 20?
21 over 20. We want 20. A question? It's good. Okay, let's go to the third property. No question so far, right? Okay, third property is said A over B plus C over D. What is the answer? No, before this one. Before this property. Let's go to the another property. Yeah, here. If I have A over C, here addition, you look, we need to add two fractions. So if the fraction, both of them have the same denominator, look, C, then the answer we just do summation for the both of numerator. A plus B over C. Because both of the fraction has the same denominator, C. I give you an example. Suppose I have 4 over 5 plus 6 over 5. What is the answer? Because both of them have the same denominator is 5. Look, 5, 5, and addition. So we keep the denominator are equal 5, and we just add the both of, we just keep the denominator 5, and we add the numerator 4 plus 6. And they give me 10 over 5. And this is equal to, we divide both simplified by 5. Is it clear? No questions so far? Okay, first one. If I want to add again a divided by b, but different denominator, a plus over b plus c over b are different, not the same. B and D are different, not the same. Here we have the same denominator. Look, C, C. Here B and D are different. So we do cross multiplication. We multiply this by B, A by B, and this by this, and the denominator. So what's the answer? They give me like this. A times B plus C times, A times D A times D plus C times B over B times D. Cross multiply. Example for this. I have, for example, 3 over 4 plus 5 over 6. What's the answer? Who will help me to answer this question? Yes, Chris.
You said you cross multiply, so you would multiply 3 times 6, and then you would add it with 5 times 4. So 3 times 6 is 18 plus 20, and then over 24, I think.
Over 24. Yes. Yeah, so 18 plus 20 over 24. What is the answer?
38 over 24.
38 over 24. You can keep it like this, or you can simplify it, whatever you want. It's okay. So here, look, B and D are not the same. B not equal to the D. Very important. Here they have the same D numerator. Here different. Different denominator, the same denominator. Okay. Now, last property. Any question before I move? Okay. Next property. It says number 5. A over AC over BC is equal A over C, A over B. That means we can do cancellation. Look, we cancel the C by the C. We can cancel only the C by the C. So they give me A over B. So it's called cancellation property. Cancellation property. Cancel what? We cancel the common factor. We cancel a common factor. Who will give me examples of this? Like for example, 4 times what? Who will give me example?
2.
2 over like 6 times what? 2. So look, 4 times 2 over 6 times 2, we can cancel the 2 by each other because they are common factor. What is the answer? It's 4 over 6. We can simplify this by dividing both sides by 2. Give me 2 over 3. Any question? Is it clear? Okay. We have another property, the last one. Right? Number 6 is the last one, not the 5. This one called if I have, for example, 2 fractions are equal to each other, A over B equal to C over D. If this fraction is equal to this fraction, this is mean then, or this mean A times B is equal to A times B. So this is equal, this is mean. Then AB is equal to BC. Who will give me examples for this that achieve this property?
Um, 4 over 6 equals 3 over 9.
This again, what is that? 3.
4 over 6,
Okay, equal
3 over 9.
8 over 9.
9. Yeah.
Okay, let me make sure, check. 4 times 9 is equal to 8 times 6. Let me make check. 4 times 9, what's the answer?
36.
36. And 8 times 6, what's the answer?
48.
48. So this is not true.
Oh, okay, I got it.
Okay. So give me another one. What about 4 over 6 equal 8 over 12? Let me check. 4 times 12 is equal to 8 times 6.
Yes.
4 times 12 is 48. Yes, exactly. And this is 48. This is true. So here in the chat, we have some questions. Christopher, he said this is the only property with the name. No, some property they have a name, but we don't need it. We need the cancellation property, and we need this for number 6. It's called cross multiply. The name for this one is called cross multiply. It is in the book on page 10. Maybe, I don't know in which page. All of them have name, not all of them, some of them. Yeah. So any question before we have 5 minutes left. I give you some examples, and next time we will continue for something new. Any question? So let me give you examples. If there is no question. Examples for you. I'm not going to solve it. First question is 1 over 4 plus 9/5. What is the answer? This is the first example.
So it's 5 plus 5 plus
me- I
what,
will
36
5 plus 36 over what?
over 20.
Yes, this is true. So another one is this is for you. Second one is 9/36 plus 5/36. What's the answer? Third one is 5/7 times 14/9. What's the answer? Fourth one is 5/7 times 3/7. The answer. And number 5, simplify 5 times 6 over 7 times 6. Is the answer. So we have 3 minutes left. You can think about this question. And if you have any question, you can ask me next class. Okay? This is for you question. I'm not going to do it today. You can think about this using the property, the sixth property for multiplication and division. And that's it for today. You're welcome. So I will stop recording for the class.
All right, take care. Have a good night.
You too. Have a good night.
Thank you, Professor.
Thank you. Have a good night.
Hello,
You too.
Professor.
Good night.
You're welcome. Have a good night.
Hello, Professor.
Yes.
I wrote you a text message and I joined class even though I'm sick. So can you please ignore the message? I text you with your phone number. Is that okay?
Phone number I can give it to you, but I can using the email. I answer the email.
I still joined the class.